re-emphasize what they look like and how we use them with the word problems and all that. It really works out to be a lot of interest problems and what do you call it? Depreciation, things like that.
Is this a new section?
It's still the same. It's kind of combining 1 and 2 together with some of the word problems. I'm trying to bring in some of the growth model, the decay model, principal interest, the rate. I'll talk about it here in a second. And it's also going to bring back in E, re-explain to you guys what E is, how things like that. As we go through this stuff, the difference between a growth model and a decay model is very simple. Growth, Y equals an A stands for your initial amount, your principal, if you will. 1 plus your rate. Your rate is always written as a decimal. They'll say, it's 5%. Remember to write it as a decimal, 0.05, things like that. And then it's to the T, where usually time is in years. Growth is 1 plus some rate, whereas decay will be 1 minus some rate. You have what's called a growth factor and a decay factor. Your growth factor is 1, it's always be larger than 1, whereas your decay factor would always be less than 1. Because obviously you're adding a percent or you're subtracting a percent from 1, or either one. That's why they call this, sometimes you'll say that what is the growth factor? This would be your growth factor. This would be your decay factor. It's the stuff in the parentheses. A stands for the initial amount. R is your rate, and this is decimal. It's usually given to you as percent, you just convert it, and then T is time. And generally it's within years, if I'm not mistaken. Just check and see what it was. It's actually more than that.
It's warmer than it usually is, but it's still
The other thing I want to look at real quick was compounding interest. I'm pretty sure there was a problem or two of that back in the day that I wasn't here. I kind of just let you guys go with it. Nobody really had any questions, so I'm assuming it wasn't that big of a deal. But just to re-emphasize what it stands for, P is your initial amount. They call it principal. It's the initial amount. Is it PL or is it PAL? Is it AL?
Principal.
We understand, right? No, I do it by chapter, and I'll take all this out, put it in the chapter, and then we put it in the next chapter.
Why do you just have a book?
This is easier than I just make notes and stuff with it, and I save it for the picture. It's lighter.
But so you take all this stuff out and then you put it somewhere else and then put chapter 4 stuff in there? So why don't you just have a new one?
Give them more binders. It's easier because it's not that much material. You can put that in a folder.
So what's N?
We'll get in there. Thank you. It's PAL. Because you're PAL with money. Okay. R is your rate again, as a decimal. So it's some percentages written as a decimal. N is the number of times it compounds in a year. So if it says it compounds semi-annually, what would N be? If it compounds quarterly, monthly, semi-monthly.
24.
Wait, I just made that up. Wouldn't semi-monthly? Oh yeah, you're right. It'd be every wouldn't that? If it was twice, it was every. So it would be 26. Because there are 52 weeks in a year.
What if it's a leap year?
You're right. I just made
What
that
if
up.
it's
So
a
never
leap
mind.
year?
If it says weekly,
52.
and if it says daily less the leap year.
65. Isn't leap year 2016 Fancy. Next year?
It's exciting. Maybe we'll be in school on February 29th. That'd be awesome.
I'll look it up. I mean, No, wait, it's in one day. It is in one day, I know. It should not be in one day. It is in one day. We do? We have it off?
And then again, T stands for the time in years. Like I said, a lot of these word problems, they were just kind of given to you guys, and when I was gone that one day, when I came back, nobody asked about anything, so I'm assuming everything was all right.
Yeah.
I just wanted to make sure, so today I was just going to kind of go over a few of these.
I was putting the percentage in, like, the first half, like, in decimal form.
Oh, you're saying like
So I was
12%
getting
was
really
12?
terrible answers.
Were you not converting it to decimal, or?
No, I wasn't converting it to decimal.
Oh, you're saying 12% was just 12? Yes.
If you put in 12%.
I want to go to your bank.
Wait, Mr. Murphy, is there a percent symbol on the calculator?
I don't know, there might be.
So, like, could you, if there was, could you put in, like, 12 and
I don't take the calculator out, look.
You
I
just
forgot
put,
it.
like,
It is, man.
Now,
Wouldn't that be pretty
we did the
easy?
decay already. Let's talk about what this E value stood for. What happens with the number
What's that
E?
link?
That number E it came from, it's called the natural base E. It comes from 1 plus 1 over n to the n. It's the compounding interest problem as it gets larger and larger and larger. As the number of times something compounds, it gets closer and closer to this value. It approximates itself to that 2.718 whatever, the number E.
Something like that.
You will.
Should I remember this too?
It's like logging and stuff. Is it a
Oh,
Christmas
yes.
present?
Yes. We watched
It's Euler's number.
It was Euler.
Wait, is
Euler, it's pronounced Euler.
this. Oh my gosh.
Paul McMahon.
This is so bad.
Little number in honor of great mathematician, Mr. Euler.
Math teacher is basic.
When I find myself in times of trouble, the wise teacher comes to me, speaking words of wisdom.
I see it a little bit.
The Beatles instead of this?
I'm sorry.
Let it be. He was standing right in front of me, speaking
All I have is the
words
Beatles
of
song in
wisdom.
my head now.
Let it be. 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 Whisper words of wisdom. Let it be. When it's the base of a logarithm, everyone would agree there will be an answer. Let it be. When that is the situation, it is natural for all to see. There will be an answer. Let it be. 2.7182 818 284 5904 523 136 028 7471 35266 249.
This was a look like I love this guy. I love
That's right.
So you should.
Huh?
How did they find that?
Guitar.
See, I'm not the clever to make these things. Why just Google stuff?
That was so good. I can try.
Wake up from my slumbering class. Wise teacher comes to me, speaking words of wisdom that I eat.
Have you had enough of this?
No, I've had enough.
Is there another verse?
I don't know. We're hoping that. I hope not. That's what the catchphrase is.
Fire flames.
I think it's a little above his singing octave.
Oh, there you go.
I'm not about this. I'm watching.
Well, that was fun. Sweet aspatotes.
Not to watch, actually.
I just kind of want to see it myself now.
Is it the same?
No.
Oh, is it the same? Here, get the light real quick so you can see it. It is the same guy!
Oh my god.
Looks like you wore that strong.
I think my dad wore that tux when he got married.
Touching not, touching no. Sweet asymptotes.
No, it's good.
Two curves never seem so close.
Ruining all these songs.
Were they good to begin with?
They did.
He must live out in the middle of nowhere with his wood shack house there.
They don't seem
That.
to cross. We draw down there.
We actually credit for remaking this. Check them out one day.
Parties.
I already know you have the tux at home, so.
I would remake
I don't know that personally, but I would imagine your dad would have it, if anything.
How can I plot when I'm
It's just creepy.
The chorus one more time.
Mine's probably. It's like
Probably.
It's an ice cream scoop.
Ruin it for everybody.
I don't know if we can do it.
It's not even done.
Yeah, very disappointed it's not dotted.
However, the next video. I think you just didn't. Hey, go to the end and see what the next video
No,
pops.
I'm done. I'm done. Anyway, so that's where you get the E value as stuff is approaching, as N gets infinitely large. That's why when we say things are compounding continuously, that's the PERT formula. So if things compound semi-annually, quarterly,
So what is this?
monthly, this is when they compound continuously. When you have a problem that has interests that are compounding continuously, it's the PERT formula. It's P E to the RT, where P is your principal. E is the E button
Where is
The
our
E button.
next to the F one. R, thank you, is your percent as a decimal. And T is time in years.
Yeah.
The E button on the Inspire
You
is,
get to push the pie and
okay, you hit pi and move over.
then
So you can say, pi, how are you?
I get it.
Close enough.
It is very funny, aren't I? R. P, it hurts. P-E to the R-T. Squid. Squid harder.
When I swing, it looks like an R, or it looks like an N when I swing.
It's an R.
No, I'm talking about at the top.
Anyway, so what we're looking at then is, I'll put this out of order by mistake. I want to look at a couple quick ideas of compounding interest and how these things calculate themselves out. So let's say you have, what's that? Oh, it's here. It's see, I thought maybe it was going to go with the Sweet Emotions with Aerosmith. That'd be impressive.
No, I was getting it.
Got it. All right, cool. So let's go back and look at, where'd it go? We're investing $2,500 into an account. What's the balance in the account after 4 years if it's compounded annually at 1.7%, monthly at 1.5, 1.2 at daily, and 0.7 continuously. So take a couple of minutes and figure that out. Give me a sec. What'd you guys get for 1.7?
2674.
Everybody agree? Okay. 1.5.
26.49.
Oh, I messed up.
Everybody agree?
Can we go?
Probably I.
Yeah, I
You-
agree.
You agree?
Okay.
Okay.
Jenna agrees and it's right.
Daily. At 1.2.
6, 2, 2.92.
Yeah.
Yeah.
And then last but not least, 0.7% continuously. What's your rate if it's 0.7%? 0.007.
Ah.
0.017.
Wait, hey, Jenna, for B, what are you raising to? Like,
Raise the two numbers. Oops. Right there.
what are those two numbers supposed to be? Why? Because you're collecting 12 times a year for 4 years. 12 times 4 is 48. Really?
Yes.
Oh. Okay.
40.
Oh! What's the time of year? How many years is it? 4 years, that's why. So, yeah, you should be your T here should be 4. That's why.
Yeah, that's right.
Thank you. We should agree to one.
Maybe just some good
Do you want to wait to do the other one later? Or you want to just try to knock it out? If you want to swing through the back and forth. You want to, because everybody had technically two.
My goodness.
So you want to just wait to do the. So I'm reason what that's the purpose.
You know it's us.
If you want, I'm just saying. Well, I'm just, that's what I usually have. Send this exactly. Because I don't think they'll take it.
How many do you have now?
It's something. When it's come up with flex What's the price? What's the price per unit is it? There is some value.
I can't run away.
About how
You
you were here that day.
We have, but it also says you guys. So let's call this a day on these things. I don't think you're going to have too much of a hassle with this stuff. What I want you guys to do is to kind of go through this. There's a mixture of some graphing problems with exponents. There are some simplifying of logs. And there's a couple of very straightforward word problems. I honestly don't think you guys are going to have too much of a hassle with this at all. On this first grouping here, when you're graphing the exponential function or the inequality, one of the things you have to remember are when you're graphing exponents, you're just picking easy values. Remember, you're going to pick values of, that simplify nicely. 1, 0, -1, -2, things like that. Because what's 3 to the first power? 3. 3 to the 0 is 1, and so on and so forth. So you're just going to pick easy numbers and plot them through. When you do the inequalities, go ahead and just plot it like you would normally. We'll talk about shading later, because you're just going to pick an ordered pair and substitute in for the shade through. Yeah, well, you guys should be able to go through these things real fast. On the second page, though, there's a couple things here about write the equations back and forth to the equivalencies. That's using your properties of logarithms. Don't use your calculator to figure out some of those things.
I'm going to go write this on the board.
And then the last page is, this third page are just examples. It's the back page that has the word problems on it, okay? Real simple stuff. I don't think you're going to have a real hassle with this at all.
Wow.
We'll go over most of this again tomorrow. One of the things I was talking with Fontana about, or I need to talk with him about, is how the quiz stuff is going to work in this unit. I honestly don't think we're going to have time to throw a quiz in here. Yeah, I don't think it's going to work though, because I won't be here on Tuesday for the math team stuff. So what I'm thinking about doing with this is taking Thursday. Yeah, right. You don't want to take home quiz. Trust me, you don't want one.
No, that'd be crazy hard. If no
You
one
make
Yeah.
it really hard.
Yeah.
What I'm looking at doing here for Thursday and Friday is to go over sections 3-3. It usually takes a couple of days to go through it. It's all the properties of logs. It's expanding, condensing, things like that. But we're going to introduce it also with natural log. The same properties, you just got to use natural log with it. It takes a little bit of time. Come Monday, then, it's going to equations. And equations and solving equations with logs, natural logs, exponential functions, things like that. I know you guys can do that because we've already done a few of them. It's really pretty simple. That will take a day or two at most. And then we're almost pretty much done. So I think there's only 5 sections in this chapter itself. We'll probably be able to just be done with this chapter, if not the end of next week, the middle of the following week, which is fine. It just works out really well. Because then that'll let us start the first few sections of chapter 4 before break, which is a lot of review of right triangle trig. So it's stuff that you've been doing a lot of. You did it back in middle school when you first learned about the Pythagorean theorem. You did a lot of it in geometry in that whole chapter 7 stuff. And then again last year, you guys got beat over the head with the unit circle. So those first couple of the units of the trig stuff are really simple. That'll lead us to break. That'll let us finish out most of the trig stuff for the semester. We're probably only going to get through half that chapter, and then we'll start reviewing for the final. So we're almost done with this first semester, believe it or not. It's crazy. Okay? Questions?